afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of Computer Science and Engineering, MLR Institute of Technology. In this video, we are going to discuss about chromatic number. Chromatic number. So before discussing about the chromatic number, we need to understand the basic important term, that is nothing but a graph coloring. So from this terminology, we are going to discuss about the chromatic number. First, we need to understand what is a graph coloring, what is meant by chromatic number, and how to calculate the chromatic number by considering some examples graphs. So first of all, definition of graph coloring. What is the definition of graph coloring? Graph coloring is the process of assigning the colors to the vertices of the graph. For example, the graph consisting of 4 vertices. This is a graph. So we need to give some colors to the graph. Red color for A, blue color for B, green color for D, again red color for C. Graph coloring means assigning the colors to the vertices of the graph. A is colored with red, B is colored with blue, C is colored with red, again D is colored with green. So this is nothing but a graph coloring. Graph coloring is the process of assigning the colors to the vertices of the graph. But one condition is there, it ensures that no two adjacent vertices. What are the adjacent vertices of A? A adjacent is B and C. Don't use the same color which is used in the color A. Suppose A consisting of red color, don't use the red color for blue as well as vertex C. B vertex and C vertex should not have the same color. So it ensures that no two adjacent vertices of the graph are colored with the same color. We can use other colors. The vertex which is adjacent vertices, we should not use the same color. We can use other colors for graph coloring. That is the main condition. And third one is a chromatic number. Chromatic number means how many number of colors we are using. Suppose we are using red, blue, green, that is 3 colors. That minimum number of colors. That means we should maintain minimum number of colors that are required to color the graph. Then it is called as a chromatic number. Here red, don't use the red color. We can use either blue color or it is a green color. Here also we can use a red color because here it is blue, here it is a blue. So these two are not adjacent. This is adjacent one is blue color. This adjacent one is blue color. So this is that is the chromatic number. Chromatic number is 2. We can use only 2 colors to color the graph. The chromatic number for this graph is 2. So what is a chromatic number? Minimum number of colors that are required to color the graph is called as a chromatic number. So this graph coloring is also called as a vertex coloring because we have to color the vertices of the graph. That's why it is also called as a vertex coloring. It ensures that there exists no edge in the graph. We should not concentrate on the edges. We should concentrate on the vertices of the graph. So it is always we should not bother about the edges. We can concentrate on the vertices of the graph. So in the case of end vertices are colored with the same vertex. This is A, B. These are the end vertices. These are the end vertices. End vertices are colored with the same color. Such a graph is called as properly colored. It is A is end vertex, D is end vertex. D and A having the same color, then it is called as a properly colored graph. End vertices are consisting of the same color, then we can say that it is the properly colored graph. So consider some example. We need to find the chromatic numbers for the following graph. What is the definition of chromatic number? Minimum number of colors. that are required to color the graph. Minimum number of colors that are required to color the graph is called as a chromatic number. Now we need to find the chromatic number of a path graph where n is greater than or equal to 2. What is n? Number of vertices are greater than or equal to 2. What is the chromatic number? So A, B, again these are the 7 vertices are present in the graph. So we can color the first vertex with the color A, then B, color B. Then third vertex, again color A, because B is not adjacent of A. B adjacent is that is different. So we can use another color, same color as A. Next, 4. Here it is A, here it is A. We can't use B, so we can color with B. Again A, B, again A. So all the adjacent vertices are having different colors. For the path graph, the total number of colors are only we can use color A and color B. The chromatic number for path graph is 2. What is the chromatic number? Chromatic number for path graph is 2. The chromatic number is denoted by the symbol like lambda of P7 means the number of vertices are 7. So equal to 2 means total the chromatic number for this graph is 2. Next, we need to find the chromatic number for the fallen graph. These are called as cycle graphs. Cycle graphs. So first one is cycle graph 3 because of 3 vertices. First, A is colored with red. A is colored with red. And C is colored with, don't use the red color for C and B because we are already used the red color for A. So we can use green. We can use green color. So for B, don't use red, green. We can use another color called B. So what is the chromatic number for cycle graph 3? That is 3. That is 3. Next. So this is the cycle graph of 4. That means 4 vertices can form this cycle. So we can call it as a cycle graph 4. What is the chromatic number for cycle graph 4? Vertex A colored with red. Don't use red color for B and B. We can use another color. We can use here red color. Because these two vertices are not adjacent. We can use green color here. Then what is the chromatic number for the cycle graph 4? That is 2 only. That is 2. Next. So cycle graph of 5. So first of all, this we can use red color. Don't use red here. We can use here red color. Next, green. We can't use the red green color here. We can use green color here. Then green, blue. That is total number of colors are 3. Total number of colors are 3. Next, cycle graph of 6. That means 6 vertices can form the cycle. So we can say that it is the cycle graph. So here the vertices is A colored with red. We can use red color here. Here it is green. We can use green. Blue. Don't use red color, blue color. So what is the cycle graph of 6? That is 3. That is 3 colors. So only we can use red color. Don't use red here. We can use red here. Okay. So this is the chromatic number. So for the vertices numbers is 3. Okay. Then we can use 5 colors. We can use 3 colors. Here we can use how many colors are required to color the graph. Here we can use red. Here we can use red. So what is the chromatic number? The first chromatic number is 3 colors are required to color the graph. Here 2 colors are required to color the graph. 5 vertices and 6 vertices. We can use red color. We can check, can we change it as red color here? We can use green color. We can use green color only. Okay, no problem. So that is 2 is also sufficient. So what we have to conclude that for the cycle graph, number of vertices are odd. Number of vertices are odd. That means first graph 3 vertices. Chromatic number is 3. If number of vertices are even. So here it is even, here it is even. Even number of vertices, the chromatic number is that is 2. So from for the cycle graph, what we are going to conclude that in the case of cycle graph, if the number of vertices are odd, then we can use 3 colors to color the graph. If the number of vertices are even, that may be here it is a 4 or it is a 6, even number of vertices. The chromatic number is 2 in the case of cycle graphs. Next. Find the chromatic number of a complete bipartite graph. First of all, what is meant by bipartite graph? Bipartite graph is denoted by using the KMN. KMN, M is nothing but a first partition and N is the second partition. N is the second partition. So in the first partition, how many number of vertices, that is denoted by M. N is nothing but a second partition. How many number of vertices are present in the second partition? First one is a K12. That means first partition consisting of one vertex, second partition consisting of two vertices. It is a bipartite graph. For all the bipartite graph, the chromatic number is 2. Now we need to verify whether this condition is satisfied or not for the complete bipartite graph. What is complete bipartite means every vertex of first partition is connected to all other vertices of second partition. So in the case of K12, so the chromatic number is 2. How can we say that it is A is colored with red? Don't use red, we can use green color. Here it is green color. What is the chromatic number for K12? That is 2. Next. So the K13, that means first partition consisting of one vertex, the second partition consisting of 3 vertices. The first one is colored with red, B always colored with green, 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 green. Because these two are not adjacent, B's are not adjacent, we can use the same color for all the vertices of B. The chromatic number for K13 is 2. That is also satisfied. Next, K22. That means first partition consisting of 2 vertices, second partition is also consisting of 2 vertices, and it is a complete bipartite graph, means every vertex of A is connected to all other vertices. Then we can say that it is a complete bipartite. So A is colored with red, and don't use red here, we can use red here. Next, for blue, we can use B and B because these two are not adjacent. What is the chromatic number for K22? Also 2. Next, K23. First partition 2 vertices, second partition 3 vertices, and every vertex of A is connected to all other vertices of B. So A to B, again A to B, A to B. This means 3 vertices. Again second vertex is connected to this vertex, and this vertex. So it is a complete bipartite graph of 2, 3. 2, 3. 2 vertices in the first partition, 3 vertices in the second partition. Total is K23. What is the chromatic number? A is colored with red. Don't use the red color for B. We can use the red color for A. And these are colored with blue. These are not adjacent. B's are not adjacent to each other. We can use another color as B. The chromatic number is 2. The chromatic number is 2. Next, K33. That means 3 vertices are present in the first partition. three vertices are present in the second partition. A is connected to all other vertices. Here also A is connected to all other vertices and A is connected to all other. It is a complete bipartite graph. So what is the color for A? We can use red color. For all A's colored with red, for all B's colored with blue, because A's are not adjacent to each other, we can use the same color. So the chromatic number for K33 also 2. So what we can say that from all this graph is the chromatic number for complete bipartite graph is 2. So what is a complete bipartite graph means every vertex of first partition is connected to all other vertices of the second partition. Then we can say that it is a complete bipartite graph. For the cyclic graph, the number of vertices are odd. Chromatic number is 3. If the number of vertices are even, the chromatic number is 2. That is the cyclic graph. Whereas coming to the complete bipartite graph means the vertices of the first graph is connected to all other vertices in the second partition. We can say that it is a complete bipartite graph. Complete bipartite graph chromatic number is 2. Consider the next example. Find the chromatic number for the following graph. This is called as a wheel graph. This is a wheel graph. How many vertices are there? A, B, C, D, E, F, G. That means total. So that is 7 vertices are there. So first of all, so G. What is the degree of G? 1, 2, 3, 4, 5, 6. The degree is 6. Next, vertex A. 1, 2, 3. 3. Next, vertex B. 3. Vertex C. 1, 2, 3. Vertex D. 1, 2, 3. Next for vertex E. 1, 2, 3. For F, the degree is 3. Next, for G, we can use color as red. Don't use 1 for any color because G is adjacent to all vertices. G is adjacent to all vertices. Don't use the red color for A, B, C, D, E, F. Next, A, we can use different color, that is green. Don't use the green color for F and B. We can use it for C as well as E. C we can use green color. For E also we can use green color. Next, for D, don't use the red color, green color. We can use blue color. Blue. Here also we can use blue color. We can also use blue color. So how many colors we are used to for coloring this graph? That is 3. 3 is the chromatic number. 3 is the chromatic number for the following graph. So what is the wheel graph means? In the case of wheel graph, it is connected to all other vertices. The middle vertex is connected to all other vertices. Then we can't use the same color which is colored with the middle color. We can use other colors to color the graph. Then it is called as a wheel graph. So what is the chromatic number for the wheel graph is we can use only 3 colors to color the graph. The chromatic number is 3. Next, find the chromatic number for the following graph. So, what is total number of vertices or A, B, C, D, E, F? Total. So, 6 vertices are there. We can use red color. A is red color. What are the adjacent vertices for A? B is adjacent, D is adjacent, F is adjacent. So we can't use the red color for B, F and D. We can use for C and E because these two are not adjacent. Next, B. B adjacent is C, that is different color. Adjacent is O, that is different color. Next, B. Adjacent is different color. This is red, this is red. Again we can't use blue color. These adjacents are, here it is red color, it is adjacent red color, here it is adjacent red color, it is adjacent red color. There is no vertex at the middle. So how many colors that are required to color the graph? The chromatic number is 2. Only we can use two colors only to color the graph. So that is a red color and blue color. Red and blue only, the chromatic number is 2 for the given graph. Next, find the chromatic number for the following graph. Total how many vertices? 1, 2, 3, 6 vertices are there. So if it is 6 vertices maximum, the chromatic number is 2 only, we need to verify. So start with the color A. A adjacent is E and B is adjacent, C is adjacent, D is adjacent, A is adjacent. So we can use red color. But F is not adjacent, we can use red color. We can use red color for A, for F. Next, B. So here red both are adjacent, we can use green color. Then adjacent of D, don't use green color. We cannot use red color also. A red is adjacent, here it is adjacent, it is also adjacent. Don't use green color. We can use G, that is B is not adjacent to E, we can use green color here. Next, don't use the green color here because G and E adjacent or is already colored. We can use another color as B. Next, don't use green and red. We can use blue color because C, D are not adjacent. How many number of colors are required to color the graph? Total 3 colors. Total 3 colors. Therefore, the chromatic number is 3. The chromatic number to color the graph is 3. That is the chromatic number for the given graph. So we need to remember some important points regarding the this graph coloring point. So in the case of cycle graph, if the number of vertices in the cycle graph is odd, then its chromatic number is 2. That means if you consider this cycle graph, this is the cycle graph. How many number of vertices? Odd number of vertices. The chromatic number is 3. This is already proved in the previous examples. Next, the number of vertices are even. The chromatic number is 2. Chromatic number is 2. Next, chromatic number for any planar graph is less than or equal to 4. Suppose if you consider the planar graph, it is a planar graph. So A, so what is the chromatic number? It is a planar graph. We can use red color. What are the adjacent vertices of A? A adjacent is B and C. D is not adjacent. We can use 4. Next, C. C adjacent is A, then A adjacent is B and C. We cannot use the same color. So then we can use another color. B. B adjacent is D. B adjacent is C also. Then we can't use the same color. We can use another color called green. Don't use the green color because C and B are adjacent. D is also adjacent. We can use another color called B. So if it is a chromatic number for any planar graph is less than or equal to 3. How many colors are required to color this graph? 3 colors. That is less than 4. Number is less than 4. Chromatic number for complete graph, number of vertices in the graph. So what is a complete graph means, for example, if you consider if this is the complete graph, that means every vertex is connected to all other vertices. How many colors, number of vertices in that complete graph? If you consider this graph, A is connected to B, C, D. Then B is connected to A, C, and also D. D is connected to A, B, C. C is also connected. This is a complete graph. Complete graph, number of vertices in that graph. Total vertices are 4. Then what is the chromatic number? A is colored with red. Don't use red color for blue, C and D. We can use another color. Okay. Green. Don't use the green color for C, D, A. We can use another color. Then red. We can't use blue. Then yellow. So how many colors are required? That depends upon the number of vertices in that graph. The number of vertices are 4. The total number of colors is also 4. So the chromatic number for any complete graph is the number of vertices in that graph. Number of vertices in the complete graph. The number of vertices are 4. The chromatic number is also 4 for the complete graph. Another important point is if it is a complete bipartite graph. So one more point is complete bipartite graph. The chromatic number is 2. We already discussed some examples for complete bipartite graph. That means two vertices is on the top, two vertices is on the bottom. Complete means this is connected to this one and this one. This is also connected to this vertex and this vertex. It is a complete bipartite graph. What is the chromatic number for complete bipartite graph? We can use red color for A. Don't use the red color for D and C. We can use it for B and green. So for complete bipartite graph, the chromatic number is 2. The complete bipartite graph chromatic number is 2. So what we have discussed up to now is what is a graph coloring and what is the chromatic number. So we consider one more example how to calculate the chromatic number. Suppose there are consider this graph that consisting of 6 vertices. So what is the chromatic number? Last example we discussed and we can close it. Okay, first this is vertex A is colored with the red color. Don't use the red color for B, F and E. We can use it for C. Can use it for C because A and C are not adjacent. Next, so F is colored with the green. We can't use the green color for E and B. We can use it for green here because red green. Next, again blue. Again blue. So don't use the blue color for then B. B is adjacent and here also D is adjacent. We can't use red color here because these two are adjacent. We can't use green color. This is adjacent. This is also adjacent. We can't use blue color. So we can use different color as yellow. So what is the chromatic number? So there are 6 vertices are present in the graph. Then the chromatic number for this graph is 4. We can use 4 colors to color the graph. That is the example problem for chromatic number. So what we have discussed up to now, what is meant by chromatic number, and before that what is meant by graph coloring. So what is meant by graph coloring? Graph coloring is the process of assigning the colors to the vertices of the graph. We should not bother about the edges, but what n vertices will be colored with the proper colors, then we can call it as a proper coloring graph. So how many number of minimum colors that are required to color the graph? Then it is called as a chromatic number. We already discussed some example problems on the chromatic number, and what is a cycle graph, what is a complete bipartite graph, and what is a path graph, wheel graph, and how to calculate the chromatic number for the given graph. We already considered all those things by considering the example problems. Thank you.